And we're going to end this lesson with polynomial inequalities. We have already done this with quadratic inequalities. It's the exact same process as that was. So use the graph in example 6 to determine, or use the graph of the function to solve the inequalities. So in the first one, I want to know when f of x is greater than 0. F of x is just another way to write y. So when y is greater than 0, and that's going to be everything here above the x-axis. Okay, so f of x is greater than 0 from 0 to 1. Union, because we got two parts, and then to infinity. These all get parentheses because it is greater than and not greater than or equal to. So these values are not included. And then infinity always gets parentheses. So now I need to determine when f of x is less than or equal to 0. And that is everything here below the y-axis. Okay, so we got two portions again, so I'm going to have another u. This portion here is negative infinity to 0. But this time 0 is included, so it gets a hard bracket. It's included because we have a line here, because it's greater, or it's less than or equal to. Okay, then the union, we need to represent the second portion, which is 1 to 2. These get brackets as well. For the same reason, it's or equal to. Okay, same thing here. We want to determine when f of x is less than 0. Less than is below. This portion of the graph and this portion of the graph have y values that are less than 0. So this portion here is negative 1 to 1. It's not or equal to, so we get parentheses here. And then union of 2 to infinity. And remember, we're talking about those y values here. And so this is not to negative infinity, because negative infinity would represent the y right here. But as this is going down, it's also going out more. And so it's going to keep getting bigger along those x values. So positive infinity. And then we need to represent when f of x is greater than or equal to 0, which is everything that's left, but specifically everything above the x-axis. All of these have y values that are bigger than 0. So this portion here is negative infinity to 1 to negative 1. And it's greater than or equal to, so hard bracket. And likewise here, just because this is going up, that represents the y values here. As this is going up, it's going to go out, and these x values are going to get less and less and less, so negative infinity. And then represent this portion here, which is 1 to 2. Okay. So that is solving inequalities when you have the graph. And now we need to do it algebraically. So you need to find your zeros. Luckily, these are factored for us, and that's really the hardest part of these. So we're done with that part. So now solve these to get your zeros. So when I do x minus 4 equals 0, we're going to get x equals 4. And then here, when I said x plus 6 equal to 0, we'll get x equals -6. So make your number line. We have a 0 right here at -6 and a 0 right here at 4. So now we need to come up with our test points. We have 3 different sections again. So I need 3 different test points. What's something that is to this side of -6? And I'm going to pick -7. I need something here in the middle. 0 is always a good one. And I need something that's over here, something that's greater than 4. I'm just going to go with 5. So plug those in. Okay, when I plug in -7, I go -7 minus 4 squared, -7 plus 6. We're going to plug in all of these. And then we're going to put them in our calculator. And what we care about again is it positive or negative? So this first one is a -121. So for -7, we get negative in that area. Once you put that in your calculator, arrow up, hit enter, and just edit it. So it's 0 and 0. We get 96. So my test point of 0 is positive. And then we'll change these to 5. Which is 11. We get positive here. Now, if we know our in behavior and our multiplicity rules, this should make sense. When you multiply this out, you've got 2 x's here and 1 x here, so this is x cubed. Your leading coefficient is positive. So we know that my in behavior is in opposite direction because of the cubed. You got 2 here, 1 here. And it ends up, because this is positive, it ends down. It's ending down here negatively. And it's ending up here positively. Exactly what we're showing right here. And if you look at multiplicity, multiplicity here is even, which means it touches. Multiplicity here is odd, which means it crosses. And that's exactly what happens. It starts below. It crosses through our -6 because its multiplicity is odd. It comes up here somewhere and turns around. It touches that 4. But because this is even, it bounces back and stays positive. So if you know your in behavior and you know your multiplicity, you can kind of do this without needing to pick your test points and plug in. There's nothing wrong with doing this. Okay, but just know if you know the multiplicity, you know the in behavior, you should be able to determine negative, positive, positive here. Okay, so I want to know when this is greater than 0. And it is greater than 0 when it is positive. Now, kind of wrote a bad question here. Notice that I did not highlight this 4. If I'm wanting to know when it is greater than 0, It equals 0 right here at 4. Let's just change this problem. Because if this stays greater than 0, that means we'd have to do -6 to 4 with parentheses and then parentheses 4 to infinity. We'd have that break. Let's just change this to greater than or equal to 0. And now this 4 is included because we're going to include that equals 4 portion. Okay, so now my answer is -6 to infinity. Okay, let's do it again here on B. On B, here we have x is going to equal -2. Here we're going to get x equals 4. And here we're going to get that x equals 6. So if I make my number line, we now have 3 zeros here. We've got -2. We've got 4. And we've got 6. So this time I have 1, 2, 3, 4 different sections. So if I was to pick test points, I would have to pick 4 different test points for my 4 different sections. So something less than -2. So let's go -3. Something between -2 and 4. 0 is great. Something between 4 and 6. If you want a whole number, your only option is 5. And something greater than 6. We could go 7. Let's just get crazy with it and go 10. So if you want to pick your test points, that's what you would plug in. So you would take -3 and plug it into all 3 of them. You take 0, plug it into all 3. Take 5, plug it into all 3. Take 10, plug it into all 3. But I'm going to use endpoint behavior here. So if I was to multiply this all out, we'd have x times x times x. So we would get x cubed. So that's odd. And I have nothing negative out in front here. So we have even. So I know because this is even, x times x times x is a positive x cubed. I know it's going to end up. And I know because that this is odd, they're going to end in opposite directions. So I know it's going to end up and start down. So I know that this portion is positive, and I know that this portion over here is negative. Okay, then let's look at multiplicity. My multiplicity here is 1, 1, and 1. Because it's all odd, it's going to cross through. So this is going to start down here at 2, at -2, it's going to cross, and now it's going to be up here. So this is positive. Then it's odd again, so it's going to turn around somewhere. It's going to come back at 4, and it's going to cross through again and be negative. And then it's going to turn around somewhere and come here to 6, and it's still odd, so it's going to cross through and be positive. So I know my negative, positive, negative, positive here because I know my ends and I know my multiplicity. Now, if you plug in -3, you should get a negative number. If you plug in 0, you should get positive. If you plug in 5, you should get negative. If you plug in 10, you should get positive. If you use these test points, it should show exactly what we just did. So all of that to now say, I want to know when x is less than or equal to 0. So we are talking about my negative portion here and my negative portion here. So my answer is -infinity to -2 with a bracket, because it's or equal to. And then I will have the union, got 2 different sections, 4 to 6. And if you use your graphing calculator and just put that in, you should also be able to see exactly this.